Good morning, everyone. So, today we are going to go over reflections. Like reflections, probably my favorite. Dilation's my favorite, but they're one of the better transformations, in my opinion, because they're just so nice to work with. So, let's get started. What is a reflection? It is, the common sense notion of it is it's like a flip. It's a flip over a line called the line of reflection. Line of reflection. Each point and its image are the same distance. Same distance from the line of reflection. So we'll see what that looks like in a little bit. And a reflection is also an example of what we call a rigid motion, because it does not affect the size of the figure that we are reflecting. Rigid motion. So yeah, like I said, the most common way to think about it is just you're flipping a figure over a line. So in this picture we have over here, our line of reflection is the y-axis, and you flip the triangle ABC over it to get the triangle A prime, B prime, C prime. Let's see, there we go. And if you notice, I'll draw a little like dotted line. So like look at the distance from B to the y-axis. So it's 1, 2, 3 spaces over. And so how far away is B prime? Well, it's 1, 2, 3 spaces over. Meaning that, if I were to make a point here in the middle, these segments here and here are equal to each other. And that's what it means when it says each of the pre-image points and the image points are the same distance from the line of reflection. They have the same distance. So we can do this for C is 1 point away. So C prime is also 1 point away from the y-axis. A is 1, 2, 3, 4 away. And A prime is 1, 2, 3, 4 away. So that's what it's talking about. Basically, your line of reflection is bisecting the lines that connect each point or each pre-image point to its image point. So, common lines of reflection. So we already saw the one in the last picture was the y-axis. It's very common. And so is the x-axis. Two very common lines of reflection. Any horizontal or vertical lines. So we'll get some equations that's like x equals some value, some number, or y equals some number. If you can recall from Algebra 1, when you have x equals something, like x equals 5, that means your graph is a vertical line at where 5 is on the x-axis. And an equation of y equals some number, like y equals 2, is a horizontal line at 2 on the y-axis. And then another type of line of reflection we'll be dealing with are diagonal lines. So the equation y equals x, or y equals negative x, something like that. Those are diagonal lines. Y equals x is the positive slope. Y equals negative x would be a negative slope. So let's get started. Got a triangle, ABC. So let's graph this triangle. A is -4, 1, 2, 3, 4, +2. B is +4, 1, 2, 3, 4, +7, 1, 2, 3, 4, 5, 6, 7 over here. And then C is 5, 1. So 1, 2, 3, 4, 5, 1. So that's A, B, and C. Let's connect those vertices. And we got our nice triangle. So I'm going to reflect each point over the x-axis. So basically, I'm just going to think of it the same way we did last time. Look at point A. It's 1, 2 spaces away from the x-axis. So I know the image of A prime, is going to be 1, 2 spaces away. So that point A prime has to be right here. A prime. Because, again, if we go from like this point here on the x-axis, A to that point has a distance of 2. So that line of reflection at A prime must also have a distance of 2. All right. Now let's look at B. B is 1, 2, 3, 4, 5, 6, 7 spaces away. So it means I have to move another 7 spaces. 1, 2, 3, 4, 5, 6, 7. Okay, so I know this point right here is B prime. Again, because if we look at where it intersects the x-axis, there's a distance of 7 here, so I need a distance of 7 here as well. And then finally, the point C is just 1 space away, so C prime has to be 1 space away as well. So let's put that there. Here's C prime. And again, that's because if we look at this point, it's 1 and 1. So now we can connect these vertices, A prime, B prime, C prime. And we can see we get this nice reflected figure over the x-axis. Now, let's also like compare the points. So for example, we have like A. A is the point -4, 2. And then if we look at A prime is the point -4, -2. All right, let's look at B. B is the point 4, 7. And B prime is the point 4, -7. And then if we look at C, which is the point 5, 1, then C prime is 5, -1. So you could see, just comparing the points on the pre-image to the points on the image, the only thing that changed is the y value of the coordinate changed signs. So that's just like a kind of thing to notice. All right, if I reflect over the x-axis, the only difference in the point is that the y coordinate changes its sign, and it kind of just makes sense. It's on opposite sides of the x-axis, which means, all right, like it's in the lower, like in this case, we started out in the upper portion of the grid where the positive y values are, and we reflected over the x-axis. Now it's in the lower portion of the grid, which is where the negative y values are. All right, let's do another rectangle. All right, so rectangle PQRS. So P is the point 1, 2. Q is 2, 5. 1, 2, 3, 4, 5. R is 8, 3. So 8, 3. And then S is 7, 0. So right there. All right, so that's P, Q, RS. And let's connect those points so we can see our nice rectangle. Just like that. Okay. So, basically, same idea as last time, except now we are reflecting over the y-axis. So, I'm going to take one of these points, like, let's do Q. Q is 1, 2 spaces away from the y-axis, so Q prime has to be 1, 2 spaces over. So here we have Q prime. Okay. So P is 1 space away, so P prime is just 1 space away as well. I'm probably going to have to erase that. Let's put it here. And then P prime, right there. P prime. Okay. R is 8 spaces away from the y-axis, so I have to count another 8 spaces away, which is right there. So R prime. And then S prime. S is 7 spaces away from the y-axis, so I have to move another 7 spaces away over here. S prime. Whoops. There we go. Okay. Now let's connect these vertices so we can see what's going on. Here we go. Okay. There we go. We have our nice reflected rectangle over the y-axis. And remember how I said that these, if I draw like the segment from the preimage to its image, right? Like from Q to Q prime, we know that the line of reflection bisects that line. So like Q to the line of reflection is a value of 2, and the line of reflection to Q prime must have a value of 2 as well. The other thing is that it also, the line of reflection intersects that segment at a right angle. So it's actually, we would say it's the perpendicular bisector of the segment from the image and its pre-image. So you can know, like, it's kind of obvious on a grid, all right, that's a right angle, you know, but if I was doing this not on a grid, that's how, like, you could determine, like, okay, if I'm drawn a line from the pre-image to the line of reflection, maybe I have a ruler and I measure it out and know it has to hit that line of reflection at a 90-degree angle. It has to be perpendicular to it. Maybe I'll do a video on that just to show you, because it's kind of hard to explain it. But anyway, so that's the video. In the next one, we'll cover some other different types of reflections.